Hello everyone, this is Group 7's Project 4 for Dr. Hassan Rashidi's Design and Manufacturing class. The beginning of the U.S. Industrial Revolution was marked by Samuel Slater's water-powered textile mill in 1790. He was given the name the father of the American Industrial Revolution, and his work sparked the rise of textile manufacturing and steam-powered factories. The second revolution followed in the mid-19th to early 20th century. It was characterized by the expansion of steel, electricity, and petroleum industries, as well as mass production assembly lines. The image above depicts Bessemer's steel production process. The 20th century brought about the third industrial revolution. This period introduced automation, electronics, and the development of computer technologies like CAD. These revolutions helped push U.S. manufacturing to the global scale. Present-day manufacturing, or the fourth industrial revolution, utilizes technologies such as AI, IoT, and robotics to further ramp up production and build complex components. Combining the value added from both durable and non-durable goods, the total GDP in 2023 was $2.3 trillion. This number represents 10.2% of the United States' total GDP. As seen in the figures, manufacturing spans a wide variety of products and industries. Manufacturing in the U.S. is extremely important because it not only stimulates the economy with a 2.69 times multiplier for every dollar spent, it also employs nearly 13 million Americans. IIoT, or Industrial Internet of Things, refers to the use of connected devices, sensors, and systems to improve industrial operations through real-time data collection, analysis, and automation. The implementation of IIoT into the manufacturing industry is important because of its ability to boost the efficiency of any manufacturing process. Although there may be higher upfront costs, the ability to have predictive maintenance, energy management, and improved product quality make the benefits far outweigh the higher price point. An example of IIoT being applied in the real world can be seen through the work of Siemens. Their energy-saving solution uses IoT to connect machines, energy meters, products, plants, and systems. As shown in the image, there are a series of machines that are all connected, and they share data about their current energy levels and how much time they have until they need a break. This technology ultimately leads to lower energy costs, improved production efficiency, and increased longevity of tools and machines. Virtual and digital twins are two revolutionizing technologies that are changing the manufacturing game. Both utilize IIoT to provide them with the necessary data infrastructure needed to simulate accurate models. Virtual twins model entire systems and are often used in the design and planning stages. Its unlimited simulation potential and marketability make it a much stronger tool than digital twins. However, digital twins does have its place. It models specific components of a process and focuses on perfectly mirroring those individual machines. Similar to virtual twins, it utilizes real-time data to analyze performance and detect potential problems. Boeing's T-7A Red Hawk is a pioneering example of digital twins in the aerospace industry. The use of digital twins to model production, operations, and sustainment has resulted in a 75% improvement in first-time quality and an 80% decrease in assembly time. This allowed for Boeing to take this aircraft from the design stages to full flight within 36 months. This is an incredible feat that has never been seen before in the aviation industry, and it is due to the power of digital twins. Haskell follows an EPC product delivery, which stands for Engineer, Procure, Construct. They utilize virtual twins to bring entire manufacturing facilities to life, and then market it to a large corporation in a cost-effective manner. Haskell creates high-level simulations of production facilities for many companies in the wine and spirits industry, as well as packaged goods. Their virtual models optimize material flow and create the most efficient and safe pathways for mass production. This process allows Haskell to work out any bottlenecks in the design process, which dramatically reduces costs by eliminating production interruptions. Every mechanical engineer has fantasized over Tony Stark's out-of-this-world technology in the Iron Man movies. However, that technology is becoming a reality and has multiple implications in the manufacturing world. What is augmented reality? Augmented reality is an interactive experience that enhances the real world with computer-generated perceptual information. How is it applied in manufacturing? AR can be used in manufacturing to assist field technicians with assembling components. It can also speed up quality inspections and simplify inventory management. BMW, a well-known German car brand, implemented AR glasses into their Munich pilot plant. BMW's new AR application in vehicle concept and prototype engineering has sped up the design process by nearly 12 months. The head of the plant stated, "The AR goggles and CAD data allow us to find out much more quickly whether the production worker will be able to fit the component properly in series production. That way, we need far fewer test setups." The implementation of these goggles yielded a 33% reduction in error rate and a 22% decrease in inventory identification time.
The next topic is lights out factories or dark factories. So first, what are they? They are factories that operate with minimal human activity and they function completely in the dark and completely autonomous. This is part of the Industry 4.0 or the Fourth Industrial Revolution. The history of lights out factories, they started in the 1980s and they were very important during COVID-19 because of the work modality issue. The capabilities of the lights out factory is that it can reduce accidents and increase worker safety, improve operational efficiency, reduce scrap and rework, drive more advanced maintenance strategies, and have higher value tasks for workers. The limitations are the loss of flexibility, as there is no way to make a in-the-moment change or respond quickly to an unexpected situation. There can be higher costs with the startup due to the need for more machinery. Automation is only good for simple manufacturing tasks, not complex processes. And safety and prevention, as there is no one to see stops or crashes if there is nobody on site. Some examples are Fanuc. They've had lights out factories since 2001 and they can run for 30 days without human intervention. Philips has a razor manufacturing site that is completely automated and only 9 staff members oversee quality. And there are many others like Ford, Amazon, Siemens, etc. How this can be used in manufacturing or improve manufacturing. This reduces the need for on-site human labor. And this leads to greater productivity and greater profit. This combines AI and machine learning and automated manufacturing. This allows for workers to do higher value tasks, from cleaning and quality to innovation and creativity tasks. Next is retrofitting. Retrofitting is an assessment and modification of an existing machine instead of purchasing a new one. This is in order to add higher tech components or green components for energy efficiency. And this is a very useful method until the cost outweighs that of buying a brand new machine. Some considerations that go into retrofitting to ensure that it is something that will allow us to make better and better products is the long-term business impact, whether it's worth it later down the road. The time investment, as this will take a lot of time to upgrade old machinery to match that of current generation machinery. There are engineering challenges, costs, as it could cost a little bit more to rebuild versus retrofitting the machine. And then, as I just said, the rebuild versus retrofitting, whether or not retrofitting is actually the best option in this situation. And Industry 4.0 compatibility, as that is one of the main goals of manufacturing, is to strive to hit Industry 4.0 in all of our machinery. The capabilities of retrofitting is that it increases efficiency, it is engineering optimization, and it does have some cost savings sometimes. The limitations are that it takes a lot of time depending on the size of the change, can actually end up costing more depending on the type of the change, and there are space constraints with the addition of new components. The next topic is the Kano model. The Kano model is a model to quantify customer satisfaction with product features. As you can see on the right, on the very right part of the model is excellent execution, and on the left is poor execution. On the top is high satisfaction, and the bottom is low satisfaction. All the arrows inside the model demonstrate different types of emotional responses. So there's basic, which is, must-haves or basic features, and you won't really get great customer satisfaction out of that by having done it very well. But if you have these excitement models or attractive models or features, if you do those very well, you will get very high satisfaction. And also with time, all of the satisfaction of all of these emotional response types does decrease over time. The 5 emotional response types are must be or must have basic features, performance features, attractive features, indifferent features, and reverse features. The Kano model capabilities and limitations is that it does save time and money, it helps identify priority areas, and it groups the best features, and it also is a great way to increase customer satisfaction on the products that you are manufacturing. The limitations, though, is that it is predominantly quantitative, not qualitative. It requires a lot of analysis, and it also can be very hard to manage when you have products that have multiple features and multiple different types of features. The next topic is ergonomics and human factors. The definition of ergonomics is dealing with the physical aspects of human behavior, such as how a human sits or how someone grabs onto a knife. The next is human factors. This is dealing with the psychological capabilities of humans, like what is appealing, what you don't like, and they are important because all products that are used by humans, and therefore ergonomics and human factors are the most important factors when considering product design. On the right, you can see an example of what ergonomics would look like for someone using a seated desk or a standing desk. There's like the eye height, the elbow height, the seat height, the sitting elbow height, the sitting eye height, multiple things that need to be taken into consideration when designing products. Some other considerations that need to be taken are good UI and good UX, which come into the ease of use for the customer, and these actually do make or break a product. If the customer can't use the product very well, then it doesn't matter if it's a good idea or not. Improving safety, forcing functions such as not being able to shift into reverse without your foot being on the brake. This prevents unintended actions to be formed for safety. And also simplicity. Unnecessary features is subtraction by addition, where you make the product worse by adding more unnecessary things.
Product benchmarking involves comparing performance metrics of a product against competitors or industry standards. These metrics and comparisons provide valuable insight to help optimize current products and create improved future products. Benchmarking is important because it identifies performance gaps and areas of improvement. Furthermore, it helps refine product features and customer satisfaction to help staying competitive in the market. There are multiple types of benchmarking such as internal, competitive, or performance, functional, generic, and many others, all of which contribute to gaining insight and identifying areas for improvement within a product, industry, or even a company. These techniques can be leveraged to design and manufacture better products by setting clear performance goals through comparison and evaluation with competitors or benchmarks. Capabilities of product benchmarking is that it's able to highlight the strengths and weaknesses of a product relative to its competitors, providing useful insight into the capabilities of the product. Furthermore, it can help align with customer needs as it highlights opportunities to differentiate products that better fit customer expectations. Some limitations to product benchmarking is that the obtained metrics may focus too much on competition, hence hindering the development of new innovations. Furthermore, the obtained data can be inconsistent through different companies or competitors, thus sometimes it is difficult to directly compare a product to another. The newest iPhone 16 showcases Apple's latest innovation through the new camera control button, action button, as well as Apple Intelligence. One key innovation is the camera control button, as it allows users to quickly access the camera app and adjust camera settings like exposure and zoom, allowing professional quality photography more accessible. Apple Intelligence is another innovation new to the iPhone 16 that integrates AI capabilities into the device, enhancing Siri's functionality for improved interactions. These new features showcases Apple's innovation techniques for user-centered design as it enhances user interface and functionality. These innovations also boost market differentiation by setting the new iPhone apart from competitors with the addition of the new camera control button. Despite the benefits new innovation brings, it could come with certain challenges such as increasing complexity. The new camera control button may confuse new users as it has a learning curve to fully utilize. Furthermore, the newly released AI functionalities brings the same difficulties as well, due to having to learn how to use Apple Intelligence. Additionally, the delayed availability of Apple Intelligence has drawn criticism, and the camera control button has sparked debate about its practical value despite the innovative incorporation of a digital camera into an iPhone. Here are the sources used for Project 4.